Okay, so we are getting down to assignment problems. So assignment problems, they're simply saying this is where organizations assign workers to various workstations in order to minimize costs or maximize revenue. Then we get into what we call assignment problem rules. So the first rule in assignment problem is that balance the table. The summation of the rows should go to summation of columns. If the table is not balanced, balance it by creating a dummy with zero values. Then the other aspect is that we always solve the problem as a minimization. If the problem is for maximization, change it to a minimization simply by selecting the largest value from the table and subtract other values from that number, including itself. Okay, that is the rule number 2. Rule number 3 is that we subtract the rows. Select the smallest value in each row when subtracting. Okay, then the other one is that subtract the columns as per row table. So subtract the columns as per row table. Then the other rule is that you count most zeros. Okay, and rule number 6 is that the number of cancellations must be equal to number of either rows or columns. So if the number of cancellations are not equal to number of either rows or columns, select the smallest value from the uncancelled numbers, subtract it from other uncancelled numbers, and add it back to where you have cancelled twice. Okay. Then the other one is that we assign where we have zeros, but start assigning where you have only 1 0 in a given row. So these are the assignment problem rules. And these rules are by the method of what we call method of Hungarian. Okay, so this is what is going on. All right. So I say these are Hungarian method rules. All right. So you can now get into the question. So these are the rules. Okay, balancing the table, the rows and columns are supposed to reconcile. Solving a table as a minimization. If the table is for maximization, change it to minimization. You subtract the rows, select the smallest value in each row when subtracting. Subtract the columns as per row table. Cancel most zeros. The number of cancellations must be equal to number of either rows or columns. The number of cancellations not equal to number of either rows or columns. Select the smallest value from uncancelled numbers, subtract it from other cancelled numbers, and add it back to where you've cancelled twice. Then assign where you have zeros, but start assigning where you have only 1 0 in a given row. All right, so we can look at this question. So the question reads, the marketing manager wants to assign salesmen to 4 cities. He has 4 salesmen of varying experience. The possible profit for each salesman in each city is given in the following table. So we have the salesman and cities 1, 2, 3, 4, and then find out the assignment that which maximizes profit. So we are looking at this as a maximization type of an assignment problem. All right. So the way we are supposed to sort out this kind of equation is that we need to change the table because we always solve the table as a minimization. So we need to change the table to minimization. Okay, so but before we do that, we have the sales name. Okay, so salesman this way. So salesman that we can have 1, 2, 3, 4. Okay, so we have salesman 1, 2, 3, 4. Okay, so 1, 2, 3, 4. All right, and then here we have the cities. So in the cities, we have also 1, 2, 3, 4. All right. Okay, so this table is balanced. 4 salesmen, 4 cities. So we have the 25 here, 27, we have 28, we have 38, we have 28 here, we have 34, we have 29, we have 40, we have 35, we have 24, we have 32, we have 33. Okay, then we have 24, we have 32, we have 25, we have 28. Right, so this table is balanced. So we have a table is balanced. Right. Okay, so good afternoon. Good afternoon. Hello, good afternoon. So the table is balanced. Then the other aspects that we look at here, solve the table as minimization. Solve table as minimization. Okay, so What we are simply saying is that the rule number 2 says that we always solve the table as a minimization. So if the table is for maximization, change it to minimization simply by selecting the largest possible value from the table and subtract other values from that number, including itself. Okay, so what is going to happen here is that the largest value from the table, okay, from this table, largest value is 40. Okay, so this 40, subtract all other values from that number, including itself. Okay, so we're going to have, all right, so this is what we are going to have. Okay, and we have 1, 2, 3, 4. The largest table is the largest value is 40, subtracting all other numbers from 40, including itself. So here you are going to have 15. Then here you are going to have 13. Then you are going to have 12. Okay, so we are going to have a 12 here. Then here you are going to have a 2. Here you are going to have 12. So 12 there. There you are going to have 6. Then here you are going to have 11. We are going to have a 0. Here you are going to have a 5. Here you are going to have 16. Here you are going to have 8. Then here we are going to have 7. Then here you are going to have 16. Then you are going to have 8. Then here you are going to have 15. And here you are going to have 12. All right, so we now go for the rows now, subtract the rows. So go into step 3, where we subtract the rows. So to subtract the rows, we would select the smallest value in each row when subtracting. So meaning that the table will come up this way. All right. So the first one, the smallest value in this row is 2. This one will be 13. This one will be 11. Then this one will be 10 and 0. Then this one will not change because the smallest value is 0. Okay, the smallest value is 0. It will be 12, 6, 12, 6, 11 and 0. This other one, it will be 0, 11, also 0. We have 11, we have a 3 and a 2. The smallest here is 8. So you're going to have 8, 0, subtracting these ones, 7 and 4. All right. So this is step 3. Here we are simply saying subtract the rows. That is step 3, subtract the rows. Select the smallest value in each row when subtracting. Then we'll go to the other one where we simply say subtract the columns as per row table. Subtract columns as per row table. Okay, so here, step 4. Okay, so step 4, subtract. So we're simply saying subtract columns as per row table. Subtract columns as per row table. Okay, so subtract columns as per row table. So here we have 1, 2, 3, 4. One, two. So here, the smallest in this column, okay, is 0. So meaning, don't change it, to start to be 13, 12, 0 and 8. Then this other one, it will be 11, 6, 11 and 0. 11, 6, 11 and 0. Then this one, it will give us 7, 7 there. Okay. 8, 0 and 4. Then this other one, 0024, 002 and 4. Okay, so where do we go now? We go into cancel most zeros, step 5. Cancel most what? Cancel most zeros. Step 5. Cancel most zeros. So the main zeros that we have here are 1, 2. Okay, so 1, 2, 3. So solution not optimal because we have only cancelled it 3 times. Solution so solution not optimal. Okay, so solution is not optimal. Why? Because we have only cancelled 3 times. Okay. Yeah, so we have only cancelled 3 times. Because we have only cancelled 3 times. Okay, so now what happens here is that look another row here. The other row that we should go for is if the number of cancellations must be equal to number of either rows or columns. If the number of cancellations are not equal to number of either rows or columns, select the smallest value from uncancelled numbers, subtract it from other uncancelled numbers, and add it back to where you have cancelled it twice. So if the number of cancellations are not equal to number of either rows or columns, select the smallest value from uncancelled numbers, subtract it from other uncancelled numbers, and add it back to where you have cancelled twice. So as we come here, we'll be able to select the smallest value from uncancelled numbers, which is a 6. All right, so 6 is the smallest value from uncancelled numbers. Subtract this number 6 from other uncancelled numbers, including itself, and add it back to where you have cancelled twice. So where you have cancelled twice is on this one. Where you have cancelled twice is only this one. Okay, so what I'm trying to say is we have yeah, okay, so this is what is going on. 1, 2, 3, 4. So we subtracted from other, so we select the smallest value from uncancelled numbers, which is a 6. Subtracted from other uncancelled numbers, including itself, and add it back to where you have cancelled twice. So here it will be 7 there, 5 here. So 7 here. There, we are going to have a 5. Then here, you're going to have a 1. Then here, you're going to have a 6. Then here, you're going to have a 0. Then here, you're going to have a 2. So you add it where you have cancelled twice. So here, a 0 has been just cancelled once here, in this one. So where you have cancelled it twice is on this one and on this one. All right, this is where you have cancelled it twice. Okay. So meaning these are going to be 0, 11, 0, 0, 11, 0, and 8. So plus 8 here. Then 8, 0, 4, and 10. 8, 0, 4, and 10. All right, so we cancel again. Cancel again. So as we cancel again, we are going to have many zeros. Okay, so many zeros here we can have 1, 2, okay, 1, 2, 3. So we need to do another cancellation. So we select the smallest value from uncancelled numbers. These are uncancelled. Okay. These are uncancelled numbers. Subtract it from other uncancelled numbers, including itself, and add it back to where you have cancelled it twice. So that's what goes on. Okay, so that's what goes on. So for this one, we start subtracting now. So you can see here you've cancelled it twice. Okay, and here you've cancelled twice. Okay, a plus, that is this and this. Okay, so subtracting these other ones. So here it used to be a 0, 0. Here you add a 1. Okay, so add a 1. So as you add the 1, it will be actually, okay, so we are getting these out. Okay, so you add a 1 to be a 9 here in this end, to be 9. Then here it used to be 10. And then here to be 0, 1, 0, 3. 0, 0, 1, 0, 3. 5, 0. Okay, so 5, 0, and 12. Okay, so 5, 0, 12. 5, 0, 12, and 0. 5, 0, 12, and 0. Then 6, 5. Okay. So 6, 5, 0, and 7. We cancel again. So the cancellation that we are going to have here will be, we have many zeros. We can have 1, 2, 3, and 4. So solution is optimal. Okay, so solution optimal. Okay, so that solution optimal, we're going to start assigning now. This way, salesman or salesman. 1, 2, the city is here. Okay, the cities. One, two, then 2, 2, 3, 2, 4, 2. So we can, okay. So 1 can go to, okay, so what we do, you can say 4 can go to 2, 4 to 2, because you start assigning where you have only 1 0 in a given row. Assign where you have zeros, but you start assigning where you have only 1 0 in a given row. Start assigning where you have only 1 0 in a given row. 1 0 in a given row. Okay, so that's what goes on. Okay. So okay, so that's why we are starting with 4 to 2. So 2 has been taken. So 2 to 4. So 2 to 4. Because the reason is that 4 to 2 has been taken. So this one had 2 options. Okay. Then this one have also 2 options. 2 options. And then this one also 2 options. Here, 2 options. This one has only 1 option. So you start with this one that has only 1 option. Okay, so that's why we said 4 to 2. Okay. So 4 to 2, 2 to 4. So 1 to 3. 1 to 3, because one had Okay, so 1, 2, 3. All right. So 1, 2, 3. Then, of course, 3 to 1. 3 to 1. So 1, 2, 3. We go to the original table now. 1, 2, 3. We can see 1, 2, 3. Go to the original table. 1, 2, 3 is 28. 1, 2, 3 is 28. 28 here. 2 to 4. 2 to 4 is 40. 2 to 4 is 40. 3 to 1. 3 to 1 is 3 to 1 is 35. 3 to 1 is 35. 4 to 2. 4 to 2 is 32. 4 to 2 is 32. All right. So the total of what we are doing becomes what? 28 plus 40 plus 35 plus 32. It's 135. So this is the optimal solution, the final solution that we have concerning the aspect of assignment problem. So this is how we assign workers to various workstations. So salesman 1 to CT3 is 28 profit that we will generate to maximize profit. So salesman 2 to CT4 is 40 profit. Salesman 3 to CT1 is 35. Salesman 4 to 2 is 32. Okay, so this is it, what goes on as we get down to the aspect of assignment problems, right? So this is how this question, right, to assign workers to these salesmen to various workstations. This is how this question was supposed to be done. All right. So this is what is going on. Okay, so this is an assignment problems, and the most important thing to take note here, the assignment problem rules. Where you balance a table, solving a problem as a minimization, coming back to it, subtracting the rows, columns, cancel most zeros. Cancellation should be equal to number of either rows or columns. The number of cancellations are not equal to number of either rows or columns. Select the smallest value from uncancelled numbers. Subtract it from other uncancelled numbers and let it back to where you have cancelled twice. And assign where you have zero and start assigning where you have only 1 0 in a given row. So this is what is going on. All right, and we end here. All right. So this is one of the important topics. All right, so we end here for now. Okay, and especially on the where we assign, we start assigning where you have only 1 0 in a given row. So that's why here we said 4 to 2, 3 to 0, 2, that is 3 to 1. Okay, so 3 to 1. Okay, the aspect here is that when 4 takes up seat 2, and salesman 2 would go to seat 4. When the 4 has been taken, the salesman 1 would go to 3. Just like that. And then this assignment comes this way. All right.